All right, let's talk about something in math that looks way scarier than it actually is: rational exponents. You might know them as fractional exponents. They can seem a little intimidating at first, but they're secretly one of the most useful tools you've got.
Okay, so you know this, right? The square root of 25. That's 5. No problem. But what if you saw it written like this? 25 to the 1/2 power. Kind of weird looking. But here's the kicker. They mean the exact same thing. So what's going on here? How is that even possible? Well, let's get into it. First up, we're going to look at roots in a whole new way. And I want you to think of this not as learning some brand new, complicated concept. Nope, it's more like seeing an old friend wearing a new outfit. You already know them. They just look a little different.
Okay, this is really the key to the whole thing. When you see a number, let's call it b, raised to the power of 1 over n, it's just a code. It's asking a simple question. What number, when I multiply it by itself, n times, gives me b? That little 1 over n exponent, it's just a fancy way of saying find the nth root.
So let's circle back to our first question. What is 25 to the 1/2 power? Well, using our new code, the denominator is 2. So it's asking what number to the power of 2 equals 25? And we all know that's 5. See? It's the exact same idea as a square root. I love this way of thinking about it because it turns scary calculation into a fun little puzzle. Let's try 81 to the 1/4 power. Okay, don't panic. Just translate it into a question. What number, multiplied by itself 4 times, gives me 81? Well, you can just try some stuff. We know 2 to the 4th is 16. That's too low. What about 3? Let's see. 3 times 3 is 9, times 3 is 27, times 3 is 81. There it is. So 81 to the 1/4 power is just 3. All right, that makes sense when the numerator, the top number of the fraction, is just a 1. But what if it's not? What if it's a 2 or a 3 or something else? Well, that's what we're about to tackle right now as we decode the full fractional exponent. So here's the general form, b to the power of m over n. And again, don't let the letters freak you out. Just think of that fraction as a 2-part instruction manual. It's a little recipe with 2 simple steps. And here's the secret to reading that recipe. The number on the bottom, the denominator, n, that tells you the root you need to take. The number on top, the numerator, m, tells you the power to raise it to. Super simple. The root is down in the, roots of the fraction, and the power is up top. Now, this is where it gets really cool. You can do those 2 steps in any order you want. You can do the root first and then the power, or you can do the power first and then the root. You'll get the same answer either way. But, and this is a huge pro tip, one of these ways is almost always way easier than the other. Let's test this out with 8 to the 2/3 power. Let's try the root first method. Okay, the root is on the bottom, so that's a 3. So we take the cube root of 8. What number times itself 3 times is 8? That's 2. Simple. Now for the top number, the power, which is 2. We just square that result. 2 squared is 4. Boom, done. See how we kept the numbers nice and small? Okay, now let's try it the other way around, power first, just to see what happens. The power on top is 2, so we do 8 squared. That's 64. Now we have to find the cube root of 64. Okay, you might know that's 4, but you got to admit, finding the cube root of 64 is a little tougher than finding the cube root of 8. We're dealing with bigger, uglier numbers. This is why taking the root first is almost always your best bet. It keeps everything manageable. At this point, you might be thinking, okay, I get it, but why? Why do we need this new notation? Can't we just stick with the good old radical sign? And that is an excellent question. This next part is the big reveal. This is where you see the real superpower that this new notation gives you. Check out this quote from Paul's online math notes. All of the properties for exponents are still valid for all rational exponents. Let that sink in. This is it. This is the whole point. All those exponent rules you learned for regular numbers, when you multiply, you add the exponents, when you divide, you subtract, they all still work perfectly. And what that means is we can take something that looks absolutely horrifying like this. I mean, imagine trying to solve this using a bunch of nested radical signs. It would be a total mess. But with our new exponent notation, it's actually kind of easy. Okay, step 1. Let's just look at the top part, the numerator. We're multiplying x to the 2/3 times x to the 5/2. The rule says we just add the exponents. So we just have to do a little fraction addition, 2/3 plus 5/2. We need a common denominator, which is 6, so that becomes 4/6 plus 15/6, which gives us 19/6. So the top is now x to the 19 over 6. All right, next step. Now we're dividing our new numerator by what's on the bottom, which is x to the 1/6. And the rule for division? We just subtract the exponents, so we have 19 over 6 minus 1 over 6. Well, that's easy. They already have a common denominator. 19 minus 1 is 18. So now we're left with x to the 18 over 6. And for the final step, look at that exponent, 18 over 6. That simplifies, right? 18 divided by 6 is just 3. So that entire horrible-looking mess from the beginning simplifies down to just x cubed. How amazing is that? That is the real power here, turning a messy radical problem into basic fraction math. Okay, so you've seen how powerful this is. But with great power comes, well, a few common traps you need to watch out for. These are the little things that can trip you up if you're not paying attention. Trap number 1 has to do with negative numbers. Here's the deal. It's totally fine to take an odd root of a negative number. For example, the cube root of -8 is -2. Why? Because -2 times -2 times -2 is -8. It works. But you absolutely cannot take an even root, like a square root or a fourth root, of a negative number and get a real answer. It's just not possible in the real number system. Okay, this next one is huge. Pay attention to the parentheses because they change everything. On the left, the parentheses are around the -16. That means we're trying to take the fourth root of a negative number. As we just said, no real answer. But look at the right. There are no parentheses. That means the exponent only applies to the 16. So you do that first. The fourth root of 16 is 2. Then you apply the negative sign at the front. The answer is -2. See? Totally different outcomes. And the last trap, and maybe the most common point of confusion, please, please, please do not mix up negative exponents and fractional exponents. They are completely different animals. A negative exponent tells you to flip the number, to take its reciprocal, 1 over b to the n. A fractional exponent tells you to take a root. One means flip, the other means root. Totally different jobs. All right, let's wrap this up. Let's bring it all home and talk about the big idea, the one thing you really need to remember from all this. It's what I like to call your new math superpower. Here it is, the big takeaway. Every single root you've ever seen is just an exponent wearing a disguise. That's it. Radicals and exponents aren't two separate topics. They're the same thing, just written differently. And once you realize that, you can use one simple set of rules for both, which makes everything so much easier. And that brings us to the final question I want to leave you with. We've seen how powerful this one little idea is, how it lets you rewrite tricky radical problems and solve them easily. So now that you have this key, this ability to translate between these two languages of math, what else can you do? What bigger, tougher problems, maybe in higher level algebra or even calculus, can you now unlock?